Let us now have the discussion of the hyperbola with vertical transverse axis. Our given is 4y squared minus 25x squared is equal to 100. Please take note that it becomes a hyperbola with vertical transverse axis if our leading term is y squared. If the variable of our leading term is y squared, then it becomes, or it is a hyperbola with vertical transverse axis. And so this is just the same process as that of the hyperbola with horizontal transverse axis. So let's take a look at this one. So of course, the first step is to change this to standard form. And to change it to standard form, all we have to do is to divide all terms by your constant, which is 100, to make it equal to 1. So we will now have, this becomes y squared over 25 minus 25 divided by 100. This becomes 4. So we will have x squared over 4 is equal to 100 divided by 100. That becomes 1. So this is now the standard form of our hyperbola with vertical transverse axis. Always notice that it is a vertical transverse axis because our leading term, the variable of our leading term, is y squared. Okay? Now that we have a standard form, y squared over 25 minus x squared over 4 is equal to 1, then we can proceed to identifying our a, b, and c. So to find a, we have here y squared over 25. So this 25 will be our a squared. So this becomes a squared is equal to 25. And we all know that the value of a, when we extract the square root of 25, that becomes 5. For our b, this is always below our second term, so that becomes b squared is equal to 4. And the square root of 4 is 2. So the value of b is equal to 2. Now for our c, we will just use the same formula, and that is c is equal to the square root of a squared, which is 25, plus 4 squared, 2 squared, which is 4. So c is equal to the square root of 29. And by extracting the square root of 29 is 5.39 or 5.4. So that's it. After this, let's first proceed to our graphing. So our center here, since we have y squared and x squared without other term, it simply means that our center is at 0, 0. So let's now go to graphing. So 0, 0, this is our center. Now, for our A, please take note of this process. Don't get confused that A is below y squared. Since it's below y squared and y represents the y-axis, for the A, which is 5, we need to move upward and downward 5 units from the center. Always remember, because our A is just below our y squared. So let's now count 5 steps up and 5 steps down. So this will become from the center 1, 2, 3, 4, 5. And from the center 5 steps down 1, 2, 3, 4, 5. There you go. And now for our B, take note that it is below our x squared. Since it represents the x-axis, we will be using, or we will be moving 2 units from the center to the right and to the left. So we will now count 2 steps to the right, 1, 2, and 2 steps to the left, 1, 2. And so from here, when we form our rectangular thing here, connecting all our vertices and the co-vertices, we will be making use of these vertices for the triangle, for the rectangle. This, and this. Imagine that we can form a rectangle by connecting these 4 vertices and co-vertices. Let's now move on to drawing our asymptote, connecting the vertices of the formed rectangle. So we will have this becomes our asymptote. And similarly, do it to the other side. 68. There. Connect. And this becomes the equation of our, this becomes our asymptotes. Always remember that the asymptotes become our guide in the graphing of our hyperbola. And so now we're done with graphing our A and B. Let's now move on to C. And always remember, our C always denotes our foci. So therefore, from our center, since this is vertical transverse axis, we will be moving up and down 5.4 units from the center. So we will have 1, 2, 3, 4, 5.4 there. And then 5.4 units down as well. 1, 2, 3, 4, 5.4. And that becomes our foci. So let's now solve for the equations of our asymptotes. For the equation of our asymptotes, please take note of this, that our y will be equal to positive, negative a over b x. A over b x. And why is it a over bx? A simply because it is at a vertical transverse axis. So we will now have 5. Y is equal to positive, negative 5 over 2 x. So the two equations will become y is equal to 5 over 2x and y is equal to negative 5 over 2x. So from here, so 1, 2, 3, 4, 5 rise, 1, 2 run. It's rise over run. So therefore, this is your y. The positive slope is equal to 5 over 2x. And since this is a negative slope leading to the left, this becomes our y is equal to negative 5 over 2x. Those are the equations of our asymptotes. Okay, now let's move on to the latter part, the last part of our process, and that is the equation. The length of the latus rectum. So we will have here LLR, and the formula for the length of the latus rectum is 2b squared over a. 2b squared over a. So to solve this, we will have 2 times our b is 2 squared over 5. And this is 4 times 2, 8 over 5, or 1.6. So this is the length of our latus rectum. And as practice, we need to divide it by 2. So the half of 1.6 is 0.8. And from there, we will be counting the length of our latus rectum from the foci. So 0.8, it's here. 0.8. Similarly, we have 0.8 here. And 0.8 there. Now that we have these points, the latus rectum, that's our latus rectum. So we can now draw our hyperbola. So we will have from the vertices connecting our latus rectum, making sure that it will not pass through your asymptote. Similarly, here we will have this and this. And this is now the graph of our hyperbola with vertical transverse axis. Let's have another example. We have this time the center is not the origin, but HK. So the first step again is to change this to standard form, and that is by dividing 16 to all the terms. So we will have 16 divided by 4, this becomes 4. So we are left with y minus 1 squared over 4. Minus, since we only have 1 here, and 16 divided by 1 is 16, we will just retain this term. So we will have x plus 3 and the quantity squared over 16. And of course, when we divide 16 by 16, the answer will be 1. So this is now the standard form of our hyperbola. And take notice of this. The variable of our leading term is y. Therefore, it goes to show that this is a hyperbola with vertical transverse axis. So when we draw this, the orientation of our graph will be vertical in nature. So let's identify our center. Our center is it's y minus 1, that's 1. And then it's y plus 3, it changed sign, so therefore it's negative 3. Let's identify our A. For our A, it's just here, down below y, so therefore that becomes the square root of 4 is 2. That's very basic. Now let's move on with this for our B. For our B, it's right below x, so therefore the square root of 16 is 4. And finally, for our C, this is the square root of 4 plus 16. And so when we solve this, this will become C is equal to the square root of 20. And the square root of 20 is 4.47 or 4.5. So before we continue our solution, let's first graph all these values that we were able to get from our equation. So let's first start with our center. Our center is at 1, negative 3. 1 unit to the right, negative 3 down, 1, 2, 3. This is our center. Now, take a look at this. Our A is the value below y. So therefore, our movement will be up and down, 2 units from the center. So we will have 1, 2 there, and then 2 steps as well downwards. Those are our vertices now. Let's move on with our co-vertices. So for B, it's 4. And always take note that it is below our x. Therefore, your movement will be left or right, left and right, 4 units from the center. So we will have from the center 1, 2, 3, 4. And 4 units to the left, 1, 2, 3, 4 as well. Okay, try to imagine the rectangle that you can form out of these 4 points. So we will have a point here, a point there, there, and also there. So now that we were able to identify those that rectangular figure, we can now draw our asymptotes connecting those points, the vertices of our rectangle. So we will have here, don't forget to draw a broken line passing through our center. This becomes our asymptote. And remember, our asymptote guides us in drawing our hyperbola, because the graph of our hyperbola should never touch our asymptote. So to continue, this is now the other graph of the asymptote. Okay, that's it. Now that we have our asymptotes, let's identify their equations. So always remember, the equation of our asymptote here is y is equal to 1, 2. That's a positive, negative, a over b, x. So this is positive, negative. Our a is 2, rise, over our b is 4, and then just put x. So y is equal to the positive, actually it's just 1/2, positive 1/2 x when we simplify it, and y is equal to negative 1/2 x. These are the two equations of our asymptotes. Double checking it from our center, 1 step up, 2 steps right, 1 step up, 2 steps right. So we are going back to our asymptotes always. So the one with the line, the asymptote that's leaning to the right will always be your positive asymptote. So that's y is equal to 1/2 x. And the one with that's leaning to the left will be your negative asymptote. So that's y is equal to negative 1/2 x. Now that we have here, oh, by the way, don't forget to plot as well our c. So from here, we will have 1, 2, 3, 4.5 there. And then from here, 1, 2, 3, 4.5. There you go. Now, all we need to do is to solve for our LLR. When we say LLR, that's the length of the latus rectum. And the length of the latus rectum is 2b squared over a. So to continue, we will have 2 times our b is 4 squared over our a is 2. So when we cancel this, when we simplify this, we will have 4 squared, which is 16. So the length of our latus rectum is 16, and that's quite wide. Now, our original process is we need to divide it by 2 because we will be counting half of the length of the latus rectum from our foci. So the half of 16 is 8. So from here, we will be counting 8 units from our foci. 8 units to the left and to the right. So we will have 1, 2, 3, 4, 5, 6, 7, 8. There you go. And also 1, 2, 3, 4, 5, 6, 7, 8. Now with this, as you have noticed, we did not pass through our asymptotes. If that's the case, feel at ease because we are doing the right thing. feel worried if you went out of the asymptotes because you're doing the wrong value then. Similarly, down here below, we will have here 8 units to the left and 8 units to the right as well. There you go. And so now it's time for us to draw our hyperbola from our center, connecting it to our latus rectum, making sure not to intersect or pass through our asymptotes. Sorry for the not so beautiful graph, but this is the image of our hyperbola here. That's it. And the other one there, over there. Assuming that we were able to draw a perfect curve for our hyperbola. So that's it. That's how we do or graph our hyperbola with vertical transverse axis. Thank you so much.